Hey everybody, welcome to another nTop Live. My name is Andrew Reitz. I am a product engineer and computational designer here at nTopology. And today I'm going to be showing you how to create your own custom blocks in nTop platform that feel, look, and perform the same way that all the other blocks do that ship with our software. But before we jump into that, I just want to show you, if you go to nTopology.com and you go to resources and you go to videos, you can check out all the previous nTop lives. I've conducted several nTop lives in the past that have primarily focused on advanced texturing for consumer product applications. Even if you're not interested in texturing or consumer product applications, I highly recommend checking them out. In fact, I recommend checking out all the other nTop lives. They all cover really unique applications and really powerful features of the software. You'll definitely learn something, and they all come with pretty incredible example files. So definitely give them a watch. Cool, so let's jump back into nTop platform. So one of the main features of nTop platform is the ability to automate your workflows. Whether it's you build a workflow, you don't have to build it again. Whether it's something super small, like a basic utility that saves you a couple seconds of your time, or whether it's something really complex, like perhaps an engine component. With nTop platform, you build a workflow, and if it's complete, you really never have to build it again. And that workflow is now automated and available for reuse down the road. And so, yeah, workflows can vary in degrees of complexity. And for example, today, one of the workflows that I've built is something that's fairly simple. It takes a imported CAD part, it converts it into an implicit geometry type, which is our native geometry type, and then we shell that implicit geometry. If you're not familiar with shelling, shelling is where we take a solid object, which we have here, we hollow it out, and then we give the exterior surface a little bit of thickness. And so it's a lightweighting function, and super powerful. Our shelling operations never fail. It's because of our implicit geometry type. But it's a really powerful function, but that's really not the point of today's nTop Live. This is just, you can kind of consider what we're learning today as application agnostic. What we're really going to learn about is how to take a workflow that's meaningful to you, modularize it, and then set it up in such a way where you can bring it in to a notebook as a block that looks and feels and performs like all the other blocks in your system. So you might be wondering and asking yourself, what is the advantage of creating a block? Like, why should I do this? Well, the most obvious thing, and this might not be the most important thing, is certainly space. If you look at the notebook here on the left, and you look at the custom block here on the right, they're the same thing. They do the exact same thing. This is just a different medium that this notebook on the left here can take on. They edit the exact same way, but obviously there's a lot more notebook real estate that is available to me. And personally, I think it's much more easy. It's easier for a user, even though I created this, to digest and use. It's just a single block, like every other block in our system. It performs a single function. In this case, it shells a CAD body, and it has two simple inputs. And if I want to learn more about the block, I can go into the information panel, and I can check out what this block does, and I can learn more about the inputs. So yeah, one of them is space, obviously space and management and saving the real estate there in the notebook. But the other, I think, really important thing is also just workflow management. Perhaps, after I shell a CAD body, perhaps what I'd like to do is then fill the interior volume here with a lattice structure, and then join that lattice structure back to the shell body. And I actually have that example open right here. Enlarge this. So the act of taking a shelled object and then filling that with a lattice, and then joining that lattice back to the shelled object, those are some pretty distinct steps. Those are some pretty primary high-level parts of the workflow that that I can distill and package down into their own custom blocks here. And that's what I've done. And so here's an example of where I've taken our shelled body block here, which is what we're going to build today. There's then a custom block which allows you to then fill that volume with a lattice. And then there's another block which actually takes that lattice and merges it back to the shell body. So each one of these are workflows in and of themselves that I have packaged and modularized for reuse as custom blocks. And so if I drag this to the right over here, we can just take a look at how these two compare to each other. So in the notebook, I'm shelling a CAD part, but in the notebook on the right, I'm shelling, filling with a lattice, and then merging the two. And so you can see the notebooks in size are comparable in length. So you can see the value that that also brings in terms of managing workflows. Much easier to manage these complex workflows when they're compartmentalized as blocks. And I think the last point that I want to make about custom blocks and why they're so important is that, you know, if I'm an author of a block and I want to share this with others in my organization, whether it's utility or it's a proprietary workflow that I want to share with others in my organization or within a group of my organization. If I'm not the author, if I'm an end user, I believe it's much easier to receive that workflow as a custom block for several reasons. One, I have a task that I need to perform, and if I receive this custom workflow, this workflow as a custom block, it's just a single block that has a very clear name, Shellcat Body. It has two inputs that need to be satisfied. And if I need to learn more about what this block does, I can go into the information panel, I can read the description, and I can read the description for each individual input and learn about the output. So as an end user, it's much easier for me to receive a workflow in that fashion than in this fashion. Not that this is unacceptable, of course, you can definitely do that, but one of the benefits of a custom block is that you're also explicitly hiding certain parameters from the end user, even the end user is yourself. And so if we look at the notebook on the left here, we have our key inputs. But if you go into the body of the notebook, each one of these steps has several parameters. And there's a lot of parameters that don't need to be exposed in order for this workflow to function. I've only exposed the file path and the body thickness. And we'll get into what those are. But basically, I've extracted from a workflow the key parameters that I want to expose to myself and other end users. So that way, down the road, when I come back to this workflow, I know exactly what to do. I know exactly how to use it. Okay, so now we're going to build this workflow together, and these files will be available after the nTop live session. But we're going to build this notebook, this workflow. We're going to clean it up, and we're going to set it up in such a way where you can import it as a custom block. And we're going to learn some of the best practices and the basic rules to follow when creating a custom block. So that way you can create an arsenal of custom blocks for yourself. Yeah, so let's dive right into it. I'm going to open up a new instance of nTop platform. So the first thing we want to do is we want to build this workflow. And again, this workflow, you can kind of consider it, this nTop Live is agnostic of application, but we're going to build a simple workflow that imports a CAD part. So we're going to do import part, and we're going to import a CAD part. We're going to do this impeller. And it can be any CAD part. I'm going to import this part. So this is a VREP model. So this could be any CAD part. The idea is that this is a solid part. And what we want to do is we want to shell it. So we want to lightweight it and produce an interior void inside of this to make it lighter. So in order to do that, what we have to do is convert it into our implicit geometry type. So I'm going to double click to select the entire body. I'm going to right click and I'm going to say convert CAD body to implicit body. So what this is going to do is take the VREP, it's going to convert it into our native geometry type, so that way I can perform a bunch of really powerful functions on this impeller. Let that run for a second. Cool, so now we have this implicit geometry that represents our impeller. And so the last step is we just want to shell this. So I'm going to go to the search bar here, I'm going to type in shell. You can see that there's a whole bunch of other functions here called shell, but we'll take a look at those later. So I'm going to select the first one, just the original shell command. So the shell command requires a body to shell and a thickness and a direction for the shelling to take. So I'm going to drag and drop this implicit body here into our body input, and then I'll just specify a thickness of 1 millimeter. Cool. So on the exterior, it doesn't look like anything has changed, but if you hit X, the shortcut for section cut, alternatively, you can go to View, and you can select section cut. So select your object and press the hotkey X. You can create a section cut through your object. And what you can see here is that we have hollowed out that solid object. And now we've taken that exterior surface and we've essentially offset it inward 1 millimeter in thickness. So that's the basic workflow that we're going to utilize today. But again, this applies, what I'm showing you today applies to all workflows. So let's say this workflow is more or less complete. This is, I want to modularize this. I want to reuse this, you know, maybe on a weekly basis, monthly basis. The workflow is done. I essentially never have to build this again. This is perfect. It takes a CAD body and shells it. And so what I want to do is I want to now, first, before I prep it to become a custom block, I want to clean up the notebook itself. And so as best practice, what I always like to do is like to turn the key steps into variables, because we do reuse each one of these blocks downstream. So I'm going to right click, I'm going to say make variable. Alternatively, I could hit Control plus M with a hotkey. So I'm going to call this my CAD part. Down here, this implicit body, I'm actually going to remove this _1. I actually like the name implicit body because that's what it is. We've taken our CAD body and we've converted it into an implicit. I also personally note that it's an implicit because of the color of this block. When a block is green, it's telling me as an end user that this block outputs an implicit geometry type. And then lastly, what I want to do is I want to right click and make this a variable as well. I'm going to call this our shelled part. The reason I want to do that, because it's actually, the reason why this is a variable is because we do need it to be a variable in order to turn it into an output for a custom block. So I'll show you that in a second. Okay, so we've turned these into variables. And then the next step I want to do before we start setting this up to turn into a custom block is I just want to clean up this file. I want to, I'm the author of this workflow. And what I want to do is just write notes to myself, comments, to remind myself or explicitly write out like what does each step do. So I'll say like step 01, I'm going to say import CAD part. And then beneath this for the implicit body, I want to say step 01, sorry, step 02, convert the CAD body to implicit geometry. And then lastly, I just want to label the shelling part. So step 03, shell the implicit geometry. If I were to share this notebook with somebody else, the purpose of this is that they know what each step does. Also, too, if I revisit this notebook down the road, if I need to make a modification, I can always look at this and say, oh, okay, I know what this step does. This is a fairly simple workflow, but obviously workflows can get much more complicated with a lot of real-world applications. And writing comments to yourselves about like what each block does can be really important, really helpful, especially for revisiting a file later on in time. Okay, so the notebook is cleaned up. It's ready now to be prepped to turn it into a custom block. And so what do we need to do to actually create a block? If we look at any block in nTop platform, a block has a name, in this case, shell, has some inputs, and it also has an output, an implicit body. So how do we actually set up a notebook to become a custom block? Well, if you notice above the body here, this is the body section where the main bulk of the work happens for the workflow. There's a section above here called inputs, and there's a section below called output. And so I know the output for this workflow is going to be this shelled component. I know that I want to create a block that outputs what was a CAD body, but is now a shelled implicit geometry. I'm going to drag and drop this shelled part into output. So now we have our output, but what are the inputs going to be? Let's take a look at this. So if we just start from the top and work our way down, we can start to highlight the key parameters that I would want to expose, not only to myself, but to perhaps end users in my organization as well. So if we start from the top and we look at the first item, this is really important. This is the file path. If I want to make this a general purpose modular block, I want to turn the file path into a main variable that somebody can edit. So I'm going to right click, I'm going to make variable. So I'm going to keep going down the list here. Rotate Y to Z, that could be a useful parameter, but for this example, I'm going to leave this hidden. We don't need to change check model, that can stay the same. CAD body, we're deriving the CAD body from that imported part, so that doesn't need to be exposed. The tolerance does not need to change. Body is being derived from this implicit body up here. Thickness, though, is a pretty important parameter, and that's something I'm going to want to right-click and say make variable. And then direction, for this specific example, let's say shelling, we always want shelling to occur inward. We don't want to expose other options. And there are other options, such as you can shell outward, you can also shell from the center, which offset in both directions. So we've highlighted our parameters, but now what we want to do is we want to bring them up into our inputs. So with path here, I can just, to get it into the input section, I can either click and drag, like so. And for this one, which is down towards the end of the notebook, I can right click, and the very last option of this menu here is make model input. And what this will do is promote that variable to the input section of your notebook. Okay, so we're basically almost done with, I would say, an MVP of a custom block. But there's one really important thing that we want to do. First of all, we want to name this block. What is this block going to be called? Let's call this Shellcat Body. We have a name, we have some inputs, and we have a clear output. So there's one thing I want to do before I actually show you how to import this as a custom block into another notebook. What's important here is take a look at these inputs. The order of operations here is important. If I were to turn this into a block, the very first input would be thickness, and the very last input would be a file path. But that's not very intuitive. You'd want to specify thickness post understanding, like what the actual object is. So I'm going to bring this path up. I'm going to make this the first input, and this will be the first input that appears when I convert this into a block. Also, what I want to do is I don't want to have this file path embedded, because if I were to import this as a custom block, this file path would be present. So what I want to do is I want to hit backspace. I'm going to clear this. I'll leave thickness as a 1mm default, just so that there is a thickness value present. Okay, so now we're basically at the part where, okay, this is like a perfect MVP. We're going to bring this into a notebook as a block, and then what we're going to do is we're going to go back and forth a couple times and add some functionality. So what I need to do is I need to save this. I'm going to do save as. Let's go to my demo here. I'm going to call this the Shellcat Body. Now, this is really important that I'm naming my my nTop file the same as my notebook. And you'll see why in a second. So I'll save this Shellcat Body. So I'm saving my nTop file is now the same as my Shellcat Body notebook name. I'm going to open up a new instance of nTop platform. I'm just going to drag this window over. So I'm going to do file. So to bring this nTop file in as a custom block, you have to follow these steps. You can go to File, Import. And I'm going to select that nTop file, which has been set up in such a way where it can be imported as a custom block. So once it's imported, I type in Shellcat Body, and Shellcat Body appears. So the name of my notebook is now present in the search bar, and I've imported this notebook as a block. So again, that was File, Import. And the reason that this imported successfully is because I went in here and I explicitly defined two inputs and I supplied an output. If I didn't supply an output, or if I didn't specify inputs, this block would not load. Let's take a look at what we can do now to improve this. Now we know more or less how to set up a workflow so that it can be imported as a compound block. And I've showed you the process of actually importing that notebook as a compound block. And so why I was saying it's important to save your nTop file as your notebook name if you're intending to use the nTop file as a custom block is because, I could call this, whatever I want. I could call this my custom block. But if I go to import that file as Shellcat Body, I'm not going to know what the name of this notebook is. It might be difficult for an end user other than yourself, or even down the road, you might forget what you call this notebook. And so even if you import that nTop file, it's important to call the nTop file the name of the notebook, so that way you know what to search for in the search bar to have this block appear in your notebook. Okay, so great. We've successfully created a custom block, but let's add a bit more information here. If we take a look at this block, okay, Shellcat Body, that's wonderful. That's a pretty clear name. But if I look at the inputs, its path and thickness, those are somewhat intuitive, but maybe I want to learn a bit more about what this block does. So I'm going to go to this question mark icon here. And if I go to the information, I'm going to see that Shellcat Body has no description. And if I go to the path and thickness file type, or the input description, they're both blank. So even if I, as an author, remember what this is for, if I were to share this with somebody else, they might not know what this compound block does, what the custom block does. Let's go back to this file here. And let's actually, first let's change some of these names. Let's make them a bit more intuitive. Path is great, but what type of path? We want to call this our cart path. And perhaps the thickness, we want to make this our body thickness, the thickness of shelling. So we've gone ahead and we've made our inputs a bit more intuitive. But now what we need to do is add a description to the inputs, and we also need to add a description to the block as well. And so let's start with the description to the actual custom block. It's called Shellcat Body. That's really descriptive. I think it's pretty clear. And I think you should always strive to do that with your custom block name. You should always strive to have the title be concise, clear, and as explicit as possible without making the name too long. And that's why we do provide a description. If you need to make a custom block description a bit more thorough so the name is clear, that's why it's there. Even if the name is super clear, it's always, I highly recommend adding a description so that others understand what the point of the custom block is. So for Shellcat Body, let's write a description. Perhaps we'll say, follow a CAD body by converting into implicit geometry and offsetting the exterior surface inward by a specified part thickness amount. I think this is a pretty decent description. It's pretty explicit. It's kind of describing the whole journey that you take in this particular workflow. It hollows out a CAD body, and by first converting it into an implicit geometry, and then offsetting that exterior surface by a specified amount. And so it's using it's kind of describing the entire process in one sentence. Of course, this could be as long as you want it to be. In some custom blocks and some notebooks, they certainly require a longer description. Okay, great. So we've set this up. We have a clear description for our block, but now let's go ahead and let's add a description to both of these inputs here. So in order to add a description to these inputs and have them appear in the custom block information panel, what we need to do is we need to click on this icon here and add a description comment. So I'm going to say the file path of the part to import. Super simple and straightforward. It's concise, it's clear, and then I'm going to do the same thing for the body thickness. So I'm going to say thickness of body. So right now, and we'll change this description in a few moments, but right now, I think these two descriptions suffice in terms of clarifying what the inputs do. Great, so we have everything we need here to create a custom block that is clear for not only myself, but for other end users as well, if I were to share it with them. So we have Shellcat Body, we have a description for the block, we have inputs, we've relabeled the inputs to be a bit more clear, and then we've also added a description for each input as well. So if I'm going to do File, Save Shellcat Body block. I'm going to go back to our notebook here, where I originally imported that custom block. And what I'm going to do is I'm going to re-import it. I'm going to say import Shellcat Body. And you'll see that because nothing major changed about this block, we still have two inputs. All I did was basically change some text. By importing that, it automatically updated the custom blocks. You can see that our input names changed. So they changed to part path and body thickness. And if I go into the information panel, now the description that we've written below the name here appears in the information panel for Shellcat Body. And we can see that the two comments here for each input now appears as an input description for this custom block. Let's see this thing in action. Let's actually click this folder. Let's go and import a CAD part. I'm going to import that same impeller. I'll give that a moment to render. This is it's a bit more, this impeller part's a bit more complicated, so sometimes it takes a tiny bit of time to preview, but relatively not long at all. Great, so it looks like it worked, but let's double check. Let's hit the hotkey X and pick a section, cut through this object. Wonderful, it works. Great, so I've taken this simple workflow and I've converted it into a custom block. And not only have I converted it into a custom block, but I've set it up in such a way where it feels like a professional block that ships with the software. It has a clear name, has clear inputs. If you satisfy these two inputs, it will run. And if you need to learn more, you have a place to go. And again, these descriptions that you write here can be as short and concise or as thorough as you'd like them to be. And in some cases, they need to be more thorough, and that's fully acceptable. Okay, so let's say I created this custom block and I share it with the user. So let's say, they, in body thickness, they're not too familiar with this workflow, but they type in 0 by accident here. Let that run. So really this shouldn't run because you can't compute something with a thickness, you can't shell something with a thickness of 0. It doesn't make any sense. So you can see that we get an error. So this block did not run. The red question mark means that something did not run. And so just fundamentally, you can't, even though our shelling operation always works, you can't shell something with a thickness of 0, which just doesn't make sense. So what I want to do is I want to come back here to my custom block, and I want to kind of build in some guardrails. And so this is where you can start to generalize your notebooks in such a way where, there's a certain acceptable criteria that you can kind of embed under the hood so that other end users are always, they're always going to get a consistent output. They're not going to run into errors. And so, for this example, let's use, let's say that there's a certain minimum thickness and a certain maximum thickness that we want to have available. So I'm going to use the clamp block. And what we're going to do, the clamp block is a mathematical function. Add that to my notebook. And I'm going to change this from scalar to scalar, because those are the types of, that's the type of information we're working with here. And what the clamp block does, it will take a value, and if that value is below or less than the specified minimum, it will become the minimum, or if it exceeds the maximum, it'll become the maximum value. And so you can see here that my body thickness is 1 millimeter, and I'm passing it through this clamp function, and the output is 1 millimeter up here in the upper right corner. However, if I were to make this 0, the output here would be 0.25 millimeter, so that's the minimum. If I were to make this, let's say 5 millimeter, it'll clamp itself to 2 millimeter. So I'm going to change this back to 1. But I'm basically going to take this clamp function and I'm going to replace the thickness here. I'm going to hit this X on this body thickness variable chip, and I'm going to drag and drop clamp into the thickness input. And there we go. So I've implemented this function under the hood that puts some guardrails in place. And perhaps there's a specific reason for this. Perhaps there's manufacturing tolerances that people need to abide to. Perhaps the minimum acceptable thickness for a 3D print is 0.25 millimeters, or the maximum acceptable thickness is 2 millimeters. And you want to make sure that if you share this workflow with others in your organization, that they don't go below or above that value. Also, too, by putting essentially this logic in place that acts as a guardrail for the end user, you always kind of ensure that they have an output from this workflow that you've set up. But there's some work to be done here. So we've added this logic, but we want to be a bit more explicit with the end user. We want to be transparent to them and say, hey, the minimum thickness that is allowed is 0.25 millimeter, and the maximum is 2 millimeters. Just so there's no question as to why the block failed if they type in 0. And so what we can do here is we can actually, let's type this out. So the body thickness. So you can keep the basic description here, but then I can go in and add a bit more information. I can say the thickness bound to a minimum thickness of 0.25 millimeter and a maximum thickness of 2 millimeter. Any value less than 0.25 millimeter will automatically become 0.25 millimeter. Any value greater than 2 millimeter will automatically become 2 millimeter. So I wrote a very thorough description, and so if the user by chance types in a value greater than 2 and they see that their shelling isn't getting any thicker, or if they put in a value of 0, one, the block won't fail, but obviously they'll have a thickness that's not 0. And so this is providing the end user with a clear description as to what's happening here. And you'll notice that I didn't have to describe what the clamp function is. I just basically described what the clamp function does in simple terms. So one thing not to do is to say, this body thickness variable implements the clamp function, because they might not know what the clamp function does. And so just very simply writing out what this does for the end user and for yourself down the road is going to be really helpful. Okay, so I'm going to go in, I'm going to hit save. Now if we jump back over to our file here, I can do file import, Shellcat Body. And so you can already see that's automatically rerunning. And again, in this particular scenario, because I didn't change the number of inputs, I could just do file import, and this block will automatically update. So just give this a little bit of time to run. And so, cool. So this is, I'm going to select this, and I'm going to hit Control H. So this did work. It's just that when you have a really thin thickness, you have to change your resolution setting to see how it performs. But the key takeaway here is that it did function. So if I change this back to 1, this will run again. And so maybe what I'll do is actually, I'll let this run, but then what I'll do is I'll swap out this part with a completely different part, just to kind of prove the point of creating a modular, reusable, scalable custom block. Cool. Nice, looking good. And so lastly, what I'll do is just kind of round this out. I'll nTop live. Let's do a different impeller. So I've imported an impeller that's slightly different, but it's just a different CAD part altogether. And again, this functions. So if you download this file, try it out yourself. Import your own CAD part to see how this functions. Nice. This is great. Okay. So this pretty much wraps up our nTop live. Just to recap what we did. We built a workflow, we cleaned it up, and then we basically we set it up so that it can be brought in as a custom block. First thing that we did is that we made the workflow modular. We put a bow on it and said, this workflow performs X function. Now we're ready to convert this into something that can be reused as a custom block. We then set up some inputs. We went ahead and specified an output. We were cognizant of the order of the inputs. We also clearly labeled what the inputs do, so they have a description. We labeled our notebook, because the notebook name is also the custom block name. We gave the notebook a clear description, because this ultimately becomes the custom block description. And then we saved the file as the same name as our notebook. And then if we jump over here, what we did in order to bring that notebook in as a custom block, we went to File, Import. We brought that file in, and then we searched for it. Search for it in the search bar here. So Shellcat Body. This is a really powerful function enabling you and your organization to build a whole suite and library of custom blocks, whether they're simply utilities or they're proprietary workflows, or a mix of both. This is a really powerful function in nTop platform. I hope you learned something. Tune in next time for my next nTop Live. Thanks for tuning in. Bye.